All right, we are ready for the very last section of chapter 1, which is again going to be kind of a big list of things to go through. We're going to talk about exponents, then square roots, how to do all of these operations we've talked about in section 1 when they're all together, doing the order of operations, and then finally a last topic of scientific notation. So let's go ahead and get started with that list, and we're going to talk about exponents first. And we're going to break that up by first talking about positive and zero exponents first. We're going to leave negative exponents for after this. Okay, so let's first talk about what a positive and zero exponent does. So here's your definition for an exponent. An exponent is anything where you have a number and it's raised to another number. So what this means is that we have repeated multiplication going on. So we have whatever that base is multiplied times itself, however many times that exponent, that superscript, tells us. So we multiply by that base however many times the exponent says, n times. Okay, where I've used a couple of words here that you'll want to remember, where b is the base, and n is the exponent. So two things to remember there. We've got a base and an exponent, and it's just repeated multiplication. Now, zero exponents are a straightforward rule, but they're kind of hard to remember. Any number, anything to the zero power is 1. It is not 0, it is 1. So two definitions there, and that's an important one to remember with the zero exponent. All right, so let's just do some examples where we evaluate these exponents, just to make sure we understand these definitions. Also a good thing to grab your calculator and make sure you can find an exponent key on there. Typical exponent keys are little caret keys that look like this, or you might have a key that looks like this for your exponent key. Okay, make sure you're asking me in class too if you can't figure out how to do the exponent on your calculator. But for this, we want to make sure we can do these particular ones by hand, just to make sure we're understanding these exponents. So the first one I want you to evaluate is, what would you tell me 2 to the third exponent is? The best way to do this by hand is just to write out what exactly this means. So 2 to the third is 2 times 2 times 2, whoops, times 2, 3 times. Okay, the 3 comes from how many times I multiply that base together. If I take 2 times 2, it's 4, times 2 again is 8. So 2 cubed is 8. We can do this also with fractions. So I could take 2/3 and I could square it. Again, just write out what this means in order to solve for that. It means I need to take that base, which this time is 2/3, and multiply it times itself twice. Remembering that multiplying fractions means that we multiply across, right? So we have 2 times 2 here over 3 times 3. So our final answer for 2/3 squared is 4/9. All right, what about this next one? What do you get when you take 4 to the 0 power? Nothing to write out here, right? Just got to remember that rule. Anything to the 0 power is 1. Now, these next two examples are very important. This is kind of the typical place to make an error if you're going to make one with exponents. It's when we throw some negative numbers in with exponents. So I'm going to write these next two down together because they kind of go hand in hand as far as where the mistake gets made. These two problems are very different. The difference is this first one is the negative of 5 squared. 5 squared is 5 times 5. So it's the negative of 25. So my answer here is negative 25. Now when we have these parentheses containing that negative, that means the entire thing inside the parentheses is squared. So this is -5 times -5, and when I take two negatives multiplied together, I get a positive, so this answer is positive 25. So here it's a major importance to know the difference between when the negative is in parentheses, so that the exponent is acting on that negative, and when the negative is not in parentheses, so the exponent is not acting on that negative. All right. So that's positive exponents. That's about all we get when we get positive exponents here, okay? And we're only going to work with whole numbers as far as this class goes. So let's talk about now, what does it mean to have a negative in the exponent? So not a negative in the base, but a negative exponent. So we need a definition for this. If we have a negative exponent, the main thing here is that this does not make the number negative. The only thing that can make the number negative is when the negative is connected to the base. This negative is connected to the exponent. And what it means is that instead of doing repeated multiplication, you are doing repeated division. You are dividing by that base now, however many times that the exponent tells you. So what the negative does is it puts your bases in the denominator of a fraction. It divides by them instead. So b to the negative n is the same thing as 1 over b to the positive n power. Again, a negative exponent does not make it a negative number. A negative exponent means to divide. So let's make sure we've got that. Let's do some examples here. So your first one here, can you tell me what you would get if you had 2 to the -3 power? Write it out. This means 1 over 2 multiplied together 3 times. That means we have 1 over 8. A positive number since our base was positive. Now what happens if we throw in a negative base? So what if I have -2 to the -3? Now those negatives in no way cancel each other out, right? Write down what this means. This negative here means I need to do all of my multiplying in my denominator, so I'm actually dividing. And what am I going to multiply together? I'm going to multiply -2 together 3 times. Now be careful here, because -2 times -2 is +4, but then I need to take that times -2. So I have 1 over -8, which I would want to write as -1 over 8. So that is a negative because we had a negative in our base, not because we had a negative in our exponent. That meant we were dividing. Now, last time we talked about how it was important to know whether or not that negative was inside the parentheses or not. So let's see what happens when we take it outside the parentheses. What would you get here? So this means the negative of 2 divided 3 times. So we have the negative outside and we get 1 over 8. We end up with the same answer as this one here because we multiplied by a -3 times, so that base still ended up being negative. But always make sure you still understand whether or not that negative is part of the power or not, part of the exponent or not. Excuse me. All right, one last one. Can you figure out for me what 3 to the -4 is? Did you get 1 over 3 times 3 times 3 times 3? That's 1 over 81 when you multiply 3 together 4 times. Again, make sure you can put each one of these into your calculator. Just as those parentheses on this one and on this one up here were very important when we were thinking about those problems, They are very important that you plug those in correctly with parentheses to your calculator as well. So again, make sure you can get all these same answers on your calculator and make sure you can use that calculator to your advantage. All right, that's exponents for us. So hopefully that's making sense, and we're going to go ahead and move on to square roots. And exponents and square roots go hand in hand, just like addition and subtraction do, or multiplication and division. Those two operations undo each other, and that's exactly what a square root will undo. Now there's more types of roots. So a root in general, just a root, will undo any exponent. We're going to only focus on undoing that squared exponent, that exponent of 2. Okay, so square roots will undo a square. We're basically looking for the base of what we squared to get our number. So the best way I found to kind of understand this is to first just list your common squares. So we're just going to make a quick list of what happens when we square some numbers. So if I square 2, I get 4. That means that the square root, that's how we write the square root, of 4 is 2. If I undo the square on 4, I end up with that base of 2. If I have 3 squared, I get 9, because 3 times 3 is 9. That means that the square root of 9 is 3. And we can go on with this list for a little while. 4 squared is 16, so that means that the square root of 16 is 4. 5 squared is 25. That means that the square root of 25 is 5. So you can make a pretty quick list of squares and be able to do some square roots by hand. But basically any other square root that's not in this list of common squares is you would continue. So you could continue with like 6 squared being 36, and you would know then the square root of 36 by hand. But other than that, you're gonna have to calculate square roots in your calculator. So again, make sure you can find that square root key in your calculator. It will look just like this symbol, the square root symbol. Okay, so as we're going through and doing these problems, make sure that if they're in this list, you can understand what the square root is, but if they are not in this list, you can understand how to plug it into your calculator. So we know certain things like, okay, if I have the square root of any of these numbers, I can find it. I just want to figure out real quick, all right, what if I recognize that number, but there's a negative going on, and how that affects the answer? So here are some examples. So from this list, I can quickly say, okay, if I have the square root of 36, what would that be? The answer is 6. I squared 6 to get to 36. What would the answer to the negative of the square root of 36 be? That negative stays on the outside, and I just get the answer -6. But one thing that's interesting is if I put that negative on the inside of the square root, that does not have an answer. This is not a real number. And the reason for that is, remember what happens when we square something? If I take 6 times 6, I'm going to get 36. But if I take -6 times -6, I'll also get 36. So there's no way to square a number and get a negative number, because 2 negatives will always multiply together to be a positive. So you cannot have a negative under the square root and get an answer. If the negative is under the square root, it is not a real number. Now, what would you do in this case? Can you take the square root of 5 by hand? No. The only square roots we know around it are that the square root of 4 is 2 and that the square root of 9 is 3. So we do not know the square root of 5. We have to use our calculator to find this. So grab your calculator and make sure that when you plug this in, you can get the answer that we must square around. We're always going to have to estimate. So this is about 2.24. That means when we square 2.24, we will get about 5. Again, it won't be exact because we had to round this final answer here. But we can get those estimates from our calculator. So that's a square root. That's the operation that will go hand in hand with exponents. It's the operation that undoes an exponent. If that's making sense, we're going to move on to our next topic, which is the order of operations. So throughout this whole chapter, we've talked about all of our operations. We've talked about addition, subtraction, multiplication, division. We've now talked about exponents and these square roots that go hand in hand with them. So what we need to do is talk about, okay, if we have an expression that involves more than one operation, how do we handle solving that expression? So have you guys ever heard of PEMDAS before? This is your abbreviation for the order of operations. You want to be careful though with this, because what I see a lot is there's one mistake that's made right around the M and the D. Okay, so I'm going to list these order of operations out for us as well. The P means to perform anything in parentheses first. So the first thing you're going to do is perform any operation in parentheses, or some sort of, could be brackets or any kind of grouping symbol. Okay. The second thing you're going to do, so we've taken care of the P, the E means exponents. So then you're going to do any exponents, and since we know that square roots come into play there too, we're going to do any exponents or square roots next. The third thing is that multiplication and division come together. So it's not that you're going to carry out all multiplication and then all division. That is wrong. You are going to do any multiplying and dividing. So you're going to multiply or divide, but you're going to do it in order from left to right. So whatever comes first from left to right, so if division comes first, you're going to do that. And then if the next operation is multiplication, then you can do that. Okay, so very important that you do these from left to right. That's two different words there. It doesn't look like it, so I'm going to fix that real quick. Okay, and then addition and subtraction come together as well. So then you're going to add or subtract whichever one comes first, again, from left to right. Very important there. A lot of people with that mnemonic tend to think that multiplication all has to come before division, and that's just not true. Okay, so let's do some examples. These are some good ones to go through. This is not exhaustive because we can have so many different combinations of operations, right? But just some examples to look at here. So the first one I want to do is, how do we solve 3 times 5 minus 1? Look at that list and just go from top to bottom. Do you see an operation in parentheses? And we see an operation in parentheses right there, so that means we'll definitely take 5 minus 1 first. So this leaves us with 3 times 5 minus 1 is 4. Now, once there is no operation in the parentheses, you can drop the parentheses. Here, then, I have 3 times 4. I only have one operation left to do then, and that's to take 3 times 4. So my final answer is 12. All right, what about this next one? Can you take 6 minus 2 in parentheses times -4 minus 8? So again, if you have parentheses that don't have an operation between them, there's multiplication going on there. Well, what's your first step? Do any operations in parentheses first. So again, we're going to do those from left to right. 6 minus 2 is 4. -4 minus 8. This is a good test. What do you get when you take -4 minus 8? You should have gotten -12. So we have 4 times -12. Those parentheses are showing us multiplication right now. And 4 times -12 is our last operation, and we get -48. All right, can you do -5 minus 4 times 3? Now this one has no parentheses, so we need to move down the list. The next thing is exponents, but there's no exponents, so we keep going. Do we see any multiplication or division? And we do. We have multiplication right there, so it'll come first. So the first thing I need to do is focus on the multiplication problem, which is -4 times 3. So my -5 just comes down, and I need to take -4 times 3. A negative times a positive is a negative, so I have -12. That negative is holding that place of the minus sign as well. Now I have one last operation, which is to subtract. Sorry, I need to change my color here just to make sure we know this is part of the same problem. So -5 minus 12. The other way you can think about that multiplication too is that we're subtracting whatever the answer is when we have 4 times 3. 4 times 3 is 12, so I'm going to subtract 12. You can kind of bring that negative in with the problem or leave it there as the operation. Just make sure you don't lose that operation. All right, so -5 minus 12, what's your final answer? Hopefully you got -17. We're going to do quite a few of these to make sure we've got it. This next one's going to involve a lot of parentheses and brackets. So 5 minus, I'm going to use brackets just so they're separated from the parentheses. 4 minus 7 times 5 minus 9, and then I'm going to close that bracket. Again, we'll use a combination of brackets and parentheses just to tell the difference. So I can see these two are paired together, and I can see these two parentheses are paired together. But brackets don't come before parentheses or anything like that. They're all just grouping symbols. So anytime you have multiple sets of parentheses though, a good rule is to always work from the inside out. So the most inside set of parentheses is this 5 minus 9. So we're going to do that first. So I bring my 5 down. I have my bracket with my 4. I'm subtracting 7 times, and I want to carry out that operation in parentheses. What is 5 minus 9? It's -4. Then I'm going to bring down that bracket as well. I'm going to leave those parentheses there because they're showing me multiplication right now. Now I have this set of brackets, which means I need to do everything inside this set of brackets, but I have two operations in this set of brackets. I have subtraction and I have multiplication. Which one comes first? Multiplication will come first, right? Whoops, didn't mean to erase that. There we go. So we're going to multiply 7 times -4. We've got 5 minus 4, the 4 comes down, and then I'm going to focus on this problem right here. Again, I can think about it together. If I do -7 times -4, I'll get +28. So that means I need to add 28. Or I can think about it as subtracting the answer of 7 times -4. So I'd be subtracting I'd be subtracting a -28, which is the same thing as adding 28. So again, no matter how you think about what sign is connected where, you'll get the right answer as long as you don't lose the signs. I do need to carry down these brackets though, right? Those brackets are still there. I have one last operation inside of those brackets. I have 5 minus whatever 4 plus 28 is. 4 plus 28 is 32. Now those brackets kind of make it more confusing. There's no operation inside of those brackets, so I can get rid of the brackets. So really what I'm looking at, is 5 minus 32. I have one last operation, which is to carry out that subtraction. And when you carry out that subtraction, you get -27. One very important thing I want to note here too is you see all these steps I'm showing every step I need to carry out in order to solve this. When you take a test, I'll want to see all of those operations. So if you have a nice enough calculator, you can probably plug this whole thing in as long as you get your parentheses in the right place, and it'll give you this answer. But if you just give me the answer on a test without showing me how to get there, you won't get any points. So make sure you can understand how we get to that answer and show all of those steps. All right, we have yet to look at one with exponents, so let's make the last one we look at here that's like this, one with exponents. So we've got -4 here. I'm going to throw in an exponent, so times -2 squared minus 3 times 4 minus 2 squared. So a few exponents going on here. We've also got parentheses and other operations going on. So go down your list. Parentheses first. Now I do see parentheses here, but there's no operation inside of those parentheses. So those parentheses are simplified. I need to simplify these parentheses yet though, because there is an operation inside those. So I bring down everything. I take 4 minus 2, which is 2, and that is still squared. So don't lose that exponent. And now there are no operations inside the parentheses. So my next step is to do exponents. So I'm going to simplify both -2 squared and 2 squared, and I can do that in the same step just so long as I do it from left to right. So here I've got -4. If I take -2 in parentheses and square it, what's my answer? It should be a +4. -3 times 2 squared, +2 squared, is also 4. Now, what do you do next? We've got multiplication, subtraction, and multiplication. So we need to do the multiplication first from left to right. And again, I can do the multiplication together in one step as long as I do it from left to right. So I can take -4 times 4, that's -16. Whoops, get the right color here. And then I've got a minus sign, and I can take 3 times 4, which is 12. My last operation is to subtract, and when I take -16 minus 12, I get -28, and that's my final answer there. We also looked at expressions that we needed to evaluate. So I want to look at expressions that have multiple operations that we need to evaluate. So these last couple of examples are going to include that. So can you evaluate A plus B times C for A equal to -1, B equal to 3, and C equal to 4? So remember, when evaluating expressions, your first step is going to be to make sure to plug in everything in the right place. A is -1, B is 3, and C is 4. What operation do I do first? Make sure you multiply before you add. So you leave the -1 and you take 3 times 4, which is 12. -1 plus 12 is 11. Especially when there's something else going on, it can be kind of tricky to remember that order of operations, right? Don't just do your operations from left to right. Make sure you always follow the order of operations. All right, let's look at one last one where we're evaluating. On this one, I want you to evaluate A minus C over D minus B for A equal to 3, B equal to -2, C equal to 1, and D equal to 4. So always your first step is to make sure you plug these in correctly. You've got some minus signs in your expression, so be careful you don't lose any minus signs when you plug in things like negative, so be careful with this B equal to -2. A is 3 minus C, so make sure you actually plug in the value for C. That's 1. D is 4 minus B, which is -2. Again, when I'm plugging in a negative number, I like to put it in parentheses to make sure I have all the negatives in there I need. The one from the expression and the one from the number I'm plugging in. Okay, now, here we have a fraction. There's kind of a hidden order of operations here. You're always going to do all the operations in the numerators and denominators and then divide. So we're going to take the 3 minus 1 in the numerator first. That's 2 over 4 minus a negative 2. Remember, this becomes 4 plus 2 when I have minus a negative. So in my denominator, I end up with 6. Always still make sure that you simplify any fractions. 2/6 can be simplified to 1/3, and that would be my final answer for that problem. You're going to have some more expressions, some different looking expressions in your homework. Make sure you give those a try, and make sure you let me know if you have any questions. We do have one last topic to cover in this section, and that is scientific notation. So some numbers can be written in this scientific notation. We often use it with really big or really small numbers. Because when we start to get really big and really small numbers, we have a lot of zeros to write down, which can be easy to lose track of. So we'll push all those zeros together into scientific notation. So the way scientific notation looks is to always have a number times a power of 10. So 10 to an exponent. Very specifically here, that number in scientific notation is always a number between 1 and 10. Or if we're looking at a negative number in scientific notation, it could be between -1 and -10. Basically, this number here is always a one-digit number. It could have decimals behind it, but there should only be one digit in front of the decimal. Okay, so let's first look at numbers in scientific notation and figure out what number we're actually looking at, and then we'll go the other way around, because the other way is a little bit harder. So in these first examples, we are going to convert each scientific notation number to that normal notation we're used to, which is called decimal notation. Okay, so this first number is 4.16 times 10 cubed. So this is in correct scientific notation because I only have one digit in front of that decimal. So what do I do in this case? Well, remember what this means. It means I'm multiplying by 10 3 times. Now, because in our number system, each place value is worth 10, this means I'm going to move my place value 3 times. And when I multiply by 10, a number gets bigger. So that means that this number, 4.16, needs to get bigger by 3 place values. If you have an empty place value, you always hold its place with a 0. So 4.16 times 10 to the third power is the same thing as 4,160. Let's try that again. What about 8.1 times 10 to the -2? Now, do you remember what a negative exponent means? It means you're dividing. So I have 8.1 and I need to divide it by 10 twice. If I divide by 10, that makes the number smaller. So this 8.1 needs to get smaller by 2 place values since I'm dividing by 10 twice. Any empty spots I'll fill with 0. So 8.1 times 10 to the -2 power is oops, I left out my 0, don't do that, 081. Now you can put a 0 in front, that's just in order to make that decimal stand out. That doesn't change the number at all. So if you want to put that 0 out front, you can. Now sometimes that n coefficient of the scientific notation will be negative. That's all right, it just means your number in the end should be negative. So this will be good practice. What if I have negative 5.77 and I multiply it by 10 9 times? That means my number needs to get bigger by 9 place values. So I have a negative number that needs to get bigger by 9 place values. There's 2 place values, 3, 4, 5, 6, 7, 8, 9 place values. I fill in all my empty spots with zeros, and this is where you're seeing that why we use scientific notation. It keeps these really big numbers in a smaller form. So here I've got 577 with 7 zeros behind it. 1, 2, 3, 4, 5, 6, 7. We like to put parentheses every 3 to kind of get a better idea of what that number is, but it's a very big number. Very important here to realize the number was negative, so we made sure that our final answer was negative as well. All right, try this last one. Maybe pause and make sure you get the right answer. Can you do negative 9.23 times 10 to the negative 5? Did your negative number get smaller by 5 place values so that you ended up with a negative number, right? The number stays negative. It was negative from the beginning, that had 4 zeros and then the 923 behind it. Don't think that those two negatives cancel each other. It means you're taking a negative number and making it smaller by 5 places because you're dividing by 10 5 times. Okay, last topic. We want to make sure we can go the other way around. Can you write each normal number, each decimal notation number in scientific notation? So can you write 84,300,000 in scientific notation? All right, the trickiest part is to get that in, to get that first number. What you're always gonna do is you want only one number in front of the decimal place. So my first number here is 8, that means I want the decimal place behind 8. My current decimal place is always at the end of my number. So what I need to realize here is how many times that decimal place needs to move. It needs to move 1, 2, 3, 4, 5, 6, 7 times to become 8.43. We don't need any of the zeros anymore because those are going to be summed up in my exponent of 10, which counts those moves of 1, 2, 3, 4, 5, 6, 7 times. And 8.43 would need to get bigger in order to get to 84 million. So we do need to multiply by 7, so that exponent would be positive. See if you can do this one. Can you put 0.0056 in scientific notation? Your current decimal is there. You want your decimal behind that first non-zero number. You want it behind 5 so that my n is a number, a 1-digit number in front of the decimal place. So I need to move 3 times. That means I'm going to have a power of 3 on 10. My final number is going to be 5.6, but stop and think about that for a second. Right now, I'd be making 5.6 bigger. It needs to get smaller to be back to that original number. So I need to make sure that I end up with a negative exponent there. So always when you're done creating scientific notation, double check your answer and make sure you get back to that original number. All right, that's all I've got for you guys for this last section of chapter 1. So make sure you give that homework a try, and we'll see you guys with chapter 2.